Now we want to look at some actual applications of exponential functions. So this example says your grandma gave you $1,000 for your birthday and told you that you have to put it in the bank and you can only take it out when it has doubled in value. You are hoping to do this in 8 years. What annual percentage rate is necessary for you to double your money in 8 years? So the first thing is we need to recognize how much you were given. So 1,000 is the initial. If you think back to a couple sections ago, that was our A value. The second thing to note is that she wants you to have it double. So double $1,000 is not in the problem itself, but you need to calculate that. So doubled means $2,000 is when you can take it out. The next thing that we need to pay attention to is that you want it done in 8 years. So we're looking at 8 years. In every equation that we look at right now, there are two variables. The two things that we are measuring are money, first of all, and the other thing that's playing into how much money you have is time. So these are your two variables. One of them depends on the other, so that means one is x and one is y. X, if it is time, if there's time, it's almost always going to be x. I say almost because maybe there's a time where it won't be x, but I can't think of any. And then that means that money is y. What I mean by that is how much money you have depends on how long it's been waiting. So our years being 8 means that is x. Y is money. That is our doubled value. This is y. So what we're looking for is the annual percentage rate. And if you think back to our first section in chapter 5, that is our b value. We're looking for b. We need to know what our percentage of change is. So if we set up what we know, normally our function is y equals ab to the power of x. Y we know is money, x is time, a is initial value, and b is our percentage change. Well, we know our initial value is 1,000. We don't know b, but we do know that we want it finished or doubled in 8 years. Now the last piece, and this is the hardest typically for students, is we need to put 2,000 here because that's our goal. That's how much we want. So this is the equation that we need to solve. So just like the first couple examples, what we're going to do is divide by 1,000 first. These will chunga chunga, and we're left with 2 equals b to the power of 8. And what we want to do is raise both sides to the reciprocal power. So 1/8, 1/8. These chunga chunga to 1. So we have b equals, in your calculator, if you type 2 caret 1 divide 8, you should get 1.09. Now the question is, what percentage rate do you need in order to be finished doubling your money in 8 years? Well, this represents 100%, the initial $1,000. This is the additional percentage. So if you take 0.09 times 100, it equals 9. So that means 9% interest. I showed some extra steps there just so you understand where it came from, but it's this extra that is your, oopsie, that extra is where you gain interest. The next example says the price of the first portable computer in 1981 was $1,795. In 2012, the average cost of a laptop computer was $513. So that makes sense that technology is going to get a little bit cheaper over time. It's a little cheaper to manufacture. So set up an exponential equation, y equals ab to the power of x, and show each step needed to solve for the growth rate, which is b in the equation. So the first thing is We're looking at a time change from 1981 to 2012. So what we need to know is how many years that is, and that is 31 years. The other thing we're talking about here is money. So we're talking about the initial price of a computer, which is A, that's the initial, is $1,795. And then we also know that the new price is going to be $513. Now again, we have two variables we're measuring, money and time. Again, time is almost always going to be X, money will be Y then, so that means 31 years is X, and Y is this other money value. So again, it looks like B is what we're looking for. They told us here too. So Y equals AB to the power of X. We know that Y is 513. That's equal to the initial computer cost times B to the power of 31, because it's 31 years between 1981 and 2012. So to solve, we start by dividing by 1795. Chunga chunga. B to the 31st equals 0.2858. Then we raise both sides to the reciprocal power. This is B equals, and in your calculator you type 0.2858 caret 1 divide 31, close that, and you get 0.96. So you only maintain 96% of the cost each year. That means we lose 4%. The cost of a computer is decreasing, and our ratio is 0.96. That means we lost the other 4%.